Rational and irrational numbers. A rational number is a number that can be expressed as a fraction. In fact, when we write the word rational, the ratio part of it refers to a fraction. This encompasses all integers, as any integer can be expressed as a fraction. So 5, for example, can be expressed as 5/1. In this context, a fraction must have an integer numerator and denominator. So both the numerator and denominator have to be integers. An irrational number is therefore a number that cannot be expressed as a fraction. Many of these numbers are known to all students. For example, pi is one of those numbers. The irrational numbers are I've got this in quotes, bigger infinity than the rational numbers. Not all infinities are equal. And the irrational numbers are what they say is more dense on the number line than the rational numbers. Just to try and give an illustration of that, if you had a dart and you threw it at a number line and you could just hit one number, then it's more likely that that number is an irrational number. Rational numbers and irrational numbers together make up the set of real numbers. So I've got the number sets here on this diagram. It's a Venn diagram. And so we can see that the inside here are the natural counting numbers. So natural numbers start at 1 and go up by 1 each time. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. Those are the natural numbers. And of course, those are enclosed by the integers. Now, the integers are going to have things like 0, and -1, -12. But the integers are made up of all of those negatives, 0, and all of the natural numbers. Now, all of the integers, as we explained earlier on, are rational numbers because they can be expressed as fractions. Q is the set of rational numbers. And so in here we have all of those things inside, so all of the positive and negative integers, but also things like 3/4, which are not integers, -4 and 3/8. And so finally we end up with the set of real numbers, and in the outer ring here we have things like the cube root of 23 and pi and the square root of 2, which cannot be expressed as fractions.